Hey guys, welcome to video note 63. We're going to be doing three main things today. Make sure you can do these. Alright? Nothing like a good mold joke once in a while, right? So make sure to read this section of the book, but don't forget to make sure to call Avogadro if you have mold problems. Alright, so anyway, limiting reactant. A reactant that controls the amount of product formed and gets used up in a chemical reaction is called limiting reactant. So I'm going to use limiting reactant in terms of ham sandwiches. So if I have 6 slices of bread and a whole fresh sliced ham roast, how many ham sandwiches can I make? Well, you could cut this up into a gabillion pieces, right? And make a gabillion sandwiches. But guess what? If you only have 1, 2, 3, 4, 5, 6 pieces of bread, you're only going to get 4 sandwiches. So the limiting reactant is the bread because the bread will run out before the ham. All right, so you'll only be able to get, did I say 4? 3 ham sandwiches because the bread will run out first. So we call the ingredient that goes in that runs out first the limiting reactant, and then we use the limiting reactant to figure out how much product we should get. Okay, so you can think of this in terms of atoms. If these are all atoms going into a chemical reaction, and these are atoms that come, the new things that come out, if you notice, here's something new, a bond, a bond, a bond, a bond, a bond, a bond. So guess what happened? The green one's a limiting reactant, or the bigger sphere, because it gets all used up to make product. So it's a limiting reactant, gets all used up, and you'll only get 1, 2, 3, 4, 5, 6 products based on 6 limiting reactants. Will give you 6 products. All the other ones are excess reactant that is not chemically reacted and does not get used up. Okay, so definition again. A limiting reactant, sometimes called a reagent, is a reactant that controls the amount of product. Excess reactant is left over when the reaction is done. Here's a balanced chemical equation. Here's some molecules to represent it. So if we had the N2 being the bigger spheres, all right, and H2 being the smaller ones, which one's limiting? Well, it looks like we need 1, 2, we have 1, 2, 3 of the N2s, 1, 2, 3, 4, 6 of the H2s. All right, all 3 N2s get so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 H's get used up over here, but there's an extra N2 left over. So what's the limiting reactant? It's the one that gets used up, and that's the H2. H2 is limiting because it gets all used up. And when the H2 gets used up, only 4 NH3s get made. Okay? N2 is excess. Alright, so we're going to have to do this mathematically, but this is the concept behind limiting and excess reactant. Okay? Hey, it's your turn. I want you to look at this diagram, look at the balanced equation, look at the molecules, and figure out what is limiting and what is excess. And we'll talk about it in class. All right, now we got to do the math with it. So a limiting reactant is a reactant. And the way to determine a limiting reactant is to change both of the reactants into products. Because the limiting reactant tells you the most you'll be able to get out of the reaction, and it's going to be the one that gives you the least amount of product. So we start with the amount of reactant going in, reactant, right? And then we change it into product. Since this is grams, we want to go to grams of product because it's a 3-step boomch, boomch, boomch. Get rid of grams of H2, change it into moles of H2. Get rid of moles of H2, change it into product. In a limiting reactant problem, we're always going to change it into product. Now, sometimes there's more than one product, so make sure you use the product they talk about in the reaction. This one only has one product. Okay, so what happens here? We got to fill it in. Moles to grams, moles are the best, they're number 1. Periodic table, go get grams. Moles to moles, yeah, that's when you use coefficients because coefficients are moles. And when it's moles to moles, we have a 2 for the H2 and a 2 for the H2O. Moles to grams, moles are the best, they're number 1, and grams, you go get them from the periodic table. Okay, so cancel, cancel, goodbye, 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 goodbye. We're left with 181.09 grams of H2O. All right, we're not done. We just did a stoichiometry calculation to say if all of the hydrogen gets used up, this is how much water we're going to get. Now we're going to say, well, what if all of the oxygen gets used up? Well, grams to grams, boom, 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 3 conversions. Grams O2, moles O2. Moles O2, we have to change it in the product. Moles H2O. Mole H2O, grams H2O. All right, let's fill it in. Grams and moles. Moles are the best. You go get grams from the PPT. Moles to moles, coefficients are moles. There's a 1 for the O2. Oh, come back. And a 2 for the H2O. Grams to moles. Moles are the best. Periodic table for grams. Goodbye, 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 goodbye. See you later. Grams H2O. This time we get 22.8. So what does this mean? This means if all of our hydrogen gets used up, we should get this much water. If all of our oxygen gets used up, we should get this much water. So we'll never get 181.09 grams of water because there's not enough oxygen to make that much water. So oxygen is the limiting reactant because it produces less product. So the oxygen is kind of like the bread. You can only get 3 sandwiches from 6 slices of bread. You can only get 22.8 grams of water, even if you use this much hydrogen and this much oxygen, because the oxygen limits the amount of product you can get. Okay? All right. Now, another thing we're going to learn is what these answers also mean. The smaller of these two answers tells you that the reactant that gave you that was the limiting reactant. Okay. So the limiting reactant is used in stoichiometry to calculate the most product that you can get. So there's a name for that. The name of the most product that comes from stoichiometry is called a theoretical yield. Remember, yield means product. Yield means product. So the amount of product that comes from the limiting reactant is called a theoretical yield because in theory, if everything goes perfectly, that's the most you can get out. Okay. Percent yield is a comparison of what actually comes out of the lab experiment compared to what you should get using stoichiometry. Okay? So percent yield is the part over the total. The part is what you get in the lab. The total is what stoichiometry says you should have, and that's called theoretical. So here it is. Write this down. Percent yield is actual yield divided by theoretical yield. You multiply all of that times 100 to make it a percent. So let's just say actual comes from experiment. And theoretical comes from stoichiometry. And it's the stoichiometry of the limiting reactant. Okay, so this one says calculate the percent yield. Okay, so we have to do percent yield. So we need actual yield over theoretical yield times 100. All right, so we need 2 things to get percent yield. This is 85 grams of reactant and 124 grams of reactant. And this is 55.34 grams of water. Okay, so this tells you that this comes out of the reaction. So this is our actual yield. We're going to use that later. That's going to go up there. But we have to figure out the theoretical yield. So we have to do a limiting reactant problem to figure out what number goes down here. I got to take that 85.0 grams of methane, pH4, times, boomch, boomch, boomch. See how this is grams of water for actual yield? We have to have grams of water for theoretical yield. Cancel out the grams of CH4. Change it to moles. Then we change moles of CH4. Here's where we can change it into something else. Moles H2O. Why did I pick H2O? Because the actual yield is yield of water. Moles H2O and grams H2O. Okay, here we go. Grams and moles. Moles are the best, and you go get grams from the periodic table. 16.05. So I took 12 plus 12.01 plus 4.01. Moles to moles, you need coefficients are moles. Moles and moles, coefficients are moles. So I need 2 moles H2O, 1 mole CH4. Grams to moles. Moles are the best, and you go get grams from the PT. Goodbye. See you later. Goodbye. Hello, grams of water. Okay, so how many grams of water will it be? 190.87 grams. Okay, that's a lot of water. It's a lot of water. Next, well, we still don't know if CH4 or O2 is limiting. So we still have to take the 124.23 grams of O2 and we boomch, turn it into grams H2O. All right, so you get grams of oxygen to moles of oxygen. Moles of oxygen. Now we have to go to product again, moles H2O. So we can compare the same stuff, moles of H2O, grams of H2O. All right, number 10. Fill them in. Grams and moles. Moles are the best. Grams from the periodic table. Moles and moles. Coefficients are moles. 2 for water and 2 for, come back, 2 for oxygen. Okay, grams to moles. Moles are number 1, and you'll get grams from the periodic table. That's a song. You gotta remember it. Okay, see you later, moles. Goodbye, moles of water. Hello, grams of water. So I multiply that out, and I get 69.96. And that's grams of H2O. All right, so if all of the CH4 gets used up, this is how many grams of water should come out. While the oxygen gets used up, this is how many grams of water should come out. Which one is the limiting reactant? Okay, so O2 is limiting reactant because it gives less product. All right, step 1, find the limiting reactant. Okay, step 2, come on back. Step 2, now that you know that oxygen is limiting, you also know something else. You also know that this is called the theoretical yield because it's saying if all of the limiting reactant gets used up, that's the most product that could come out of the reaction. So this is saying we have a ton of ham, but only 6 slices of bread. So in theory, we're only going to get 3 sandwiches. In theory, here, we're only going to get 69.96 grams of water. That's the most we can get, all right? So then the final step for percent yield is to take the actual yield of 55.34 grams, which somebody made in the lab doing this reaction, divided by the 69.96 grams that we theoretically thought we could get. 100 says this reaction gives 79.10% yield. Now, we want chemical reactions to give 100% yield. This one's only 79.10. What does that mean? We'll find out in a little bit. Hey, look, it's another problem. You betcha it is. All right, again, 1.8 grams of aluminum, 2.43 grams of copper sulfate are reacted, and 0.8 grams of copper form. This is product. So if that's what forms, then it's an actual yield. So it says, what is the percent yield? Okay, so percent yield equals actual yield over theoretical yield, and it's 100. All right, actual we already have, so theoretical we have to get. Now, theoretical yield has to come from stoichiometry using the limiting reactant. So here we go again. Let's take our given amount of aluminum, boomch, turn it into grams of copper. Why copper? Because the product they tell us about is copper, so we got to change our reactant into copper. And then, 2.43 grams of copper sulfate, 2 sulfate, and boomch. Why 3 steps? Grams to grams is 3. Right, grams of aluminum, moles of aluminum. Moles of aluminum turn into moles of copper. Why? Because I got to go to the same product with my stoichiometry that I measured in the lab. I measured copper in the lab, so I have to go to copper using stoich. Okay. Right, moles and grams. Moles are the best. Grams you go get from the periodic table. Moles and moles. Hey, moles and moles coefficients are moles. 3 moles of copper for every 2 moles of aluminum. Grams and moles. Moles are the best. Go get grams from the pizza. Okay. See you later. Adios. Goodbye. Hello. Grams of copper sulfate to moles of copper sulfate. And then we can change the identity. Moles of CuSO4 turn into moles of copper. Why copper? Because copper is the product that we measured in the lab. So that's why we use copper in the stoichiometry. Okay. Moles are number 1 whenever they're with grams. And then you got to go get it from the periodic table. So I got copper plus sulfur plus 4 oxygen. And I get, hey, why don't I just erase it? 159.62 grams. Then moles to moles, coefficients are moles. Copper is 3. Copper sulfate's 3. Grams to moles, 63.55. Periodic table, moles are number 1. Goodbye copper sulfate. Goodbye moles of copper. Goodbye moles of copper. Hello grams of copper. Okay, I do the math and I get 6.54 grams of copper for that reactant. And I get 0.97 grams of copper for that reactant. So, which reactant is limiting? Copper sulfate is a limiting reactant because it gives less product. It gives less product, meaning it's going to get used up first. And so we'll never make this much copper because we can only make this much before this reactant's gone. So this also is our theoretical yield because it is the one that comes from the limiting reactant. So now percent yield is actual 8.88 grams of copper actually produced in the lab divided by 0.97 grams of copper comes from stoichiometry using the limiting reactant. We find out that this reaction is 90.72% yield. Okay? All right. I know it's a lot, but it's a lot of stoic for a reason. So you might be saying to yourself, hey, Self, why don't we get 100% yield? Okay, so let's look back at this. In order for this reaction to happen, these particles have to collide with those particles. And all of these particles have to turn into copper. Okay? Now, sometimes they don't collide. So a reaction might not happen. So we can't get 100%. Maybe we start in one container and we pour it into another container. And then some of the particles get stuck in this container and don't make it to that container. So they have transfer issues going from container to container. Also, sometimes we have to do reactions in water to make them happen. And there could be side reactions taking place. Okay? So if these two are fighting over here, then they can't react in the chemical reaction. If this one gets stuck in the container, it can't make it to the products. And they have to collide. This person's not going to collide with anyone, or else, and so there's no reaction there. Okay, so to review, limiting reactant is the one that gets used up and determines how much product you get. You have to use stoichiometry with both reactants and then decide which was limiting. Percent yield is the actual lab amount of product divided by the stoichiometry. Oh my gosh, stoichiometry amount of product. And then you multiply by 100 to make it a percent. And the stoichiometry amount comes from using the limiting reactant. All right, folks, back to the book. Read 12.3. Make sure to read it. And then watch out for, if you have a suspicious looking mole, make sure you talk to your doctor about it. Peace out after you read these bullet points of objectives. See ya.